So, welcome to lecture number 51. So, in today's lecture, we are going to see advanced topics in object oriented programming. So, under which, here this is the overview. So, we are going to see the concept of multi-threading and concurrency. So, that means you are going to understand what do you mean by threads, what do you mean by synchronization, and what do you mean by the parallel processing or parallelism, right. So, we will see the practical implementation in C++, Java and Python. So, once you are familiar with multi-threading and concurrency, we will go to network programming, right. So, under this we are going to see the basics of sockets, HTTP communication and protocols, right. So, then we will talk about the client server applications in C++, right. So, this we will build and we will talk about the client server applications in C++. I mean not only C++, we will talk about Java and Python as well. So, then we have to familiar with graphical user interface development, right. So, let us have the graphical interfaces using Java Swing, right, Kinter and Qt. So, then once we are familiar with the graphical interfaces, we will talk about managing events, layouts and user interaction. So, what do you mean by multi-threading and concurrency? All right. So, threads we are going to see an example, right. So, suppose assume that we have a multiple threads, right. So, in that case the ability of a central processing unit to execute the multiple threads simultaneously, suppose there are more than one thread, right, exists. So, in that case how CPU is going to execute these multiple threads in a same time or simultaneously. So, this you call it as multi-threading, right. So, this we are going to study, in fact we are going to talk about, I mean we are going to see the practical applications in C++ and Java, right. And concurrency, what do you mean by concurrency? So, concurrency is nothing but, I mean when you are having a multiple tasks, right. So, dealing these multiple tasks at once, right. So, which may or may not run simultaneously, right. So, this you call it as concurrency, right. So, that is the difference between multi-threading and concurrency, right. So, the multiple tasks will be there. So, at the same time we have to deal and we may get the result or we may not get the result, right. So, that you call it as concurrency. Parallelism, right, the parallel programming. So, here in this case assume that again you have multiple tasks. So, we have to execute the multiple tasks simultaneously to improve the performance, right. So, parallel programming. So, your task is to do one program, but you can use, right, I mean you can do or you can execute the multiple tasks or several tasks, right. So, simultaneously we are doing this. So, you call this as parallelism. So, that say for example, some of the programs may run, right, if you are using a single CPU machine. So, it may run several hours, right. So, is it possible to do, right, with the several CPUs together and get the output, right. So, you call it as a parallel programming or parallelism. So, the key components what we are going to study, as I already said, threads, right. So, threads are nothing but lightweight subprocessors sharing the same memory space. We will see an example in the programming, right. So, the next one and the next key component is the synchronization. So, here we are going to manage the resource access to avoid the conflicts, right. So, these are all the basic introduction that we are going to see, and in fact practically when you learn, right, you know what is the difference between multi-threading, concurrency and parallelism. So, when I am talking about multi-threading, what are all the benefits and challenges that you will face, right. So, definitely we have the improved performance, right. So, when you are doing the parallel execution of tasks, so my performance will be improved. I mean in fact if I do with a single machine, right, I may have, right, or if I do with a single thread, I mean it takes a lot of time, right, to complete the program, right, or to get the output, right. So, here when I do the parallel execution of tasks, so I will get the improved performance. And next point is the responsiveness, right. So, this multi-threading, so which keeps the application responsive during the long or larger task, alright. And another important benefit is the resource sharing, right. So, threads which share memory and reducing the overhead, right. So, these are all the main benefits of the multi-threading. And what are all the challenges you face? So, we have the important technical term called the race condition, right. So, the race condition is nothing but conflicts when the thread access the shared data, right. So, assume that there are two threads, they are accessing the shared data at the same time simultaneously, right. So, in that process, there will be a conflict, right. So, the conflicts when threads access shared data simultaneously. So, this you call it as race conditions. And the second one is deadlock, right. So, assume that two trains are in the same track, right, opposite side. So, you have to have some solution to get rid of this. So, same thing, right. So, here instead of train I am talking in terms of threads. So, threads waiting indefinitely for resources, correct. So, this you call it as deadlock. And third challenge you will face, debugging complexity, right. So, here you have multi-threaded bugs, right. So, which are very harder to reproduce and debug, right. So, these are all the main challenges we face in the case of multi-threading. At the same time, so we have improved performance, responsiveness and resource sharing. So, which are all the main benefits of multi-threading. So, this is a very famous interview question, threads versus processes, right. So, how do you define a thread, how do you define a processes? So, thread already we had seen it is a lightweight, right. So, also it shares the memory space of the parent process, right. So, analogy we will take, we will give a house example, right, and the threads which are faster context switching, right. So, when you have these 3 points you call these are the threads. What about processor? So, thread I said is a lightweight. So, here processors are heavier and isolated, right. So, this is having separate memory space, and threads we had seen it is faster for the context switching, right, faster context switching. So, whereas it is opposite, because of due to memory isolation these processors are slow, right, or you call it as slower context switching, right. So, we will take a practical example, the process which is nothing but a house, right. So, threads are nothing but the rooms in the house, right. So, when I am talking about the rooms in the house, they will share the resources, right. So, process is like a house and the threads are the rooms inside that house, right. So, which are sharing the resources. So, when I am talking about the separate processes, alright. So, assume that you have n processes, right. So, it is nothing but like you have n separate houses and each houses are having the own resources. So, this is how we can have the difference. So, process means it is like a house, right, you can think it is like a house, and inside the house of course you have rooms, right. The rooms are nothing but the threads. So, every threads are having the own resources. For example, if I take kitchen, so the kitchen area item will be there. If I have a bedroom, the cot, pillow, everything will be there. So, that means individually it shares the resources. So, similarly the threads, alright. So, threads they are nothing but the rooms. So, they like house we have the sharing resources. So, here you will have the sharing resources, alright. So, this is a major difference between the threads and processes, and this is a very important interview question. What is the difference between threads and processes? So, now what is the life cycle of a thread, right? So, thread states. So, we start with new. So, thread is created but not started. We are going to see some of the inbuilt functions, right. So, when you want to run the program, we are going to see some of the inbuilt functions. So, the state new, which is nothing but, so thread is being created but it is not being started. The next state is a runnable state, right. So, thread is ready to run but waiting for CPU scheduling, alright. So, you can say that it is ready, right, for running, but it will wait for CPU scheduling. Now, next state is running, right. So, now thread is actively executing. So, this state, the running state, meaning is thread is actively executing, right. The fourth state is blocked or waiting state. So, here the thread is waiting for the resource or resources, right. So, thread is waiting for a resource, and then the terminated state, that means thread has completed the execution. So, this is the lifestyle of a thread, right. So, start with new, then runnable, right, and running. So, that means it is actively executing. So, the fourth state you can call it as a blocked or waiting state, that means the thread is waiting for the resource, and the last one is terminated, that means the thread has completed the execution. So, now let us consider right, how you are creating threads in C++, right. So, what I will do here, I will write this program and I am asking you to execute, because we have done several execution, right. Maybe the case of Java I will do that. So, the case of C++, because it is not very difficult, we are already including all the header files, right. So, we will see this program how you are going to create the threads in C++, right. So, let us have the function void print numbers int n, the usual one for I is equal to 1, I less than or equal to n, I plus plus or plus plus I, C out I, right. So, now we can create the thread, right. So, for creating thread, so here you have, right. So, I have included thread, right, the header file hash include thread, line number 2. So, now let us go to the main program. So, main program we have thread T1, right. So, T1 is a thread, and then you have, you are passing 2 parameters, right. It is a 2 argument thread, right. So, what are the arguments? Print numbers, you are passing print numbers and 10. What is print numbers? Print numbers is nothing but the function, right, and 10, n will be assigned to 10, right, n will be assigned to 10, that is the meaning. So, that means when I am comparing with the states, so I can say it is runnable and running, right. So, it is start, right. So, thread has been started, that is the meaning, right. So, ready to run, but waiting for CPU scheduling, and the next stage is thread is actively executing, alright. So, the next line, the T1 is invoking join, right. So, join which is already available in the header file thread, right. So, that means it is waiting for thread to finish, right. So, here the join function, the meaning of the join function, wait for thread to finish, right. So, this is what exactly the block slash waiting, thread is waiting for a resource, right. So, wait for thread to finish, right. So, when I run this code, so return 0, when I run this code, right. So, what will happen? The thread will start, right, and will be executed, and it is also waiting for thread to finish. That means, you have to give T1 dot join, alright. So, now I am asking you, right, you can put a comment statement on line number 12, right, and see what will happen, right. So, you will get the runtime error, right, you will get the runtime error. So, put T1 dot join the comment statement, right. So, once you remove the comment statement, that means the wait for thread to finish. Suppose I do not have line number 12, right. So, it is runnable and running, right. So, but what about the wait? So, thread should wait for a resource, right, and then it has to be terminated. So, waiting and terminated, we have to have line number 12, right. So, what I will give a small exercise, remove line number 12 and see, right. So, if I put line number 12, right, wait and terminated, right, return 0 you are putting. So, you will get the output, alright. So, this is your output. So, now you can see I use line number 11 thread, right. So, this is providing, so I have created T1, right. So, this provides support for creating the thread. So, in fact, I said, right, the line number 11. So, you have over here runnable and run, right. You have created runnable and running. So, all these 3 states, alright. And then next one join. So, this ensures the main program waits for the thread to finish, right. So, this is how the basic example in C++, right, for the creation of threads, right. So, first what you do? You try this program completely and try to comment this line number 12, alright. So, that you will understand. So, certain states will not be executed if T1 does not call this join function, right. So, join function is for wait for thread to finish. So, maybe we will see in, I will run Java, right. So, here I have my thread, class my thread, which is the extending thread, right, inbuilt. So, here you have one run method system.out.println thread running, alright. So, like what we had seen in the previous program. So, similar, right. So, here we have the main, that means the driver class, public class main, which is a driver class, and here you go the main method, alright. So, here I am creating the thread, right, the object thread under my thread, class my thread, right. So, you are allocating a memory with the constructor my thread, right. So, this is the syntax for creating the thread, right. So, this is how exactly we have done in line number 11 equivalent, right. So, slightly changing in C++, it is expected. So, here it is just like you are creating an object under the class. In the right hand side you have the memory allocation and the constructor, right. So, you have created the thread. On the next line, thread dot start, right. So, we know the same meaning what we have done in the case of right here, right. So, this will start. So, here in this case this will start. So, that means it will start executing, right. See, for example, here we have written, right, extend thread or implement runnable, right. So, here you have extend thread or implement runnable, right. So, this is what we have talked about, the states, right. So, runnable in the sense thread is ready to run, but waiting for CPU scheduling, right. And the start, line number 11 start. So, it starts the thread and calls run, right. So, once the object thread is invoking start, the meaning is the function run will be executed, right. So, that means it is calling run function, run method, and we know when the run method is being executed, so then we will get the output thread running, right. So, this is what exactly happening. So, that means line number 10 you are creating a thread, and when I have that object thread is invoking start, so that means it is starting the thread and it is calling the run method, right. So, this is what exactly happening. So, we know once it is calling run method, so run method you have system.out.println statement which is printing thread running, right. So, that is what we are getting the output. Maybe what we can do in Java, we can try this. C++ I gave an exercise, in Java we will try this. I will go to the Java here, okay, the same program. So, now we will run the code. So, if we run the code Java my thread, yeah. So, you can see the output, right, thread running followed by 3 dots. So, the next concept, synchronization mechanisms, right. What do you mean by synchronization and why synchronization is required, right. So, synchronization we talked about the race condition, right. So, this will prevent the race condition, right, race condition or race conditions, right. Also, the synchronization which is ensuring consistent access to the shared resources, right. So, these two reasons, these two main reasons we require synchronization, right. The key mechanisms are locks, semaphores and monitors, all right. So, the locks which are nothing but, so you are having a explicitly lock and unlock resources, right. So, lock mechanism, the key mechanisms of synchronization is nothing but locks. So, the locks are explicitly lock and unlock resources, and the next one is semaphores, right. So, the semaphores control access to a fixed number of resources, all right. So, you can have the control access to a fixed number of resources. So, you call it as a semaphores, right. And the third one is monitors, right. The third key mechanism is the monitors. So, we talked about the explicit lock, right, explicit lock and explicit unlock resources. So, here monitors will when it is having the implicit locking, the implicit locking using synchronized blocks. So, you call it as monitors, right. So, these are all the 3 key mechanisms, locks, semaphores and monitors under the synchronization. So, these are all helpful to prevent the race condition, and it is also ensuring that you can have the consistent access to shared resources. So, the next concept we are going to see, mutual exclusions and locks, right. You call it as a mutex. Mutex is nothing but mutual exclusion. So, we are going to study about mutual exclusion and locks in C++. So, what do you mean by mutex, right? I mean, as we have already seen, so this mutex or mutual exclusion that prevents race conditions in multi-threaded programs, right. Also, this is ensuring only one thread can access a critical section at a time, right. So, you call this as a mutually exclusion or simply mutex. So, the next concept, locks, right. The locks which are useful to acquire and release a mutex. Acquire and release a mutex. And so, in fact, we are going to see with the help of lock underscore God, right, for automatic locking and unlocking, it is like RAII, right. So, what do you mean by RAII? It is nothing but resource acquisition is initialization. So, you call this as RAII, right. So, it is equivalent to that. So, the lock underscore God, so that is for automatic locking and unlocking. So, let us consider, right, with an example. Assume that your two threads, in fact, this example we are going to see in C++, right. So, assume that, so the two threads T1 and T2, they are attempting to print the numbers, right. So, now with the help of mutex, right. So, in fact, the mutex will be ensuring that thread safe access, right, to the console output. That means, it will print one by one. So, either T1, assume that it is printing, let us say 10 numbers. So, T1 10 numbers will be printed, then the thread 2's 10 numbers will be printed, or vice versa. First T2, right, will print the numbers and T1 will print the numbers. So, that means, the mutex is ensuring that, right. So, key points: locks avoid interleaved output, right, by serializing access to shared resources, right. Also, the resource acquisition is serialization, RAII, right. So, which ensures mutex is released automatically when you have the clause, right, the lock underscore God, this we are going to see, right, the lock underscore God goes out of scope, right. So, these are all about your mutexes and locks, and in fact, practically how we can implement. So, we will see in this particular program, right. So, here we are including thread and mutex, right. So, here we are including thread and mutex. So, I have the object MTX under mutex class, it is available in your hash include mutex. I have the usual function, let us say print numbers. So, this is what I talked about this in the theory, right. The print numbers, your argument is ID whose data type is integer. So, now here, right, RAII for lock, right. So, here I have the lock God class. So, this is what we talked about. So, lock underscore God of mutex, right, and here I have the lock object with mutex, call it as MTX, that object, right, the lock. So, when I am creating this object, so automatically you are passing MTX, that means the corresponding constructor will be called, right. So, this is for lock, line number 8 statement is for lock, right. And then here you have for int I is equal to 1, I less than or equal to 5 plus I, we are trying to print thread, right, this will be printed and ID colon and I is running from 1 to 5, right. So, this we are expecting. So, now we will go to the main program, like the first program that we had seen. Here I have two threads, line number 15 I have T1, thread T1, where the parameters are print numbers is nothing but the function, and then you are passing 1, that means the ID is 1 now, right, ID is 1 now. So, T1 is a thread, class thread, right. So, like you know, when you are starting this, right. So, we know that the thread has been started, right. So, this is what we studied. The first program, if you recall, we have started, we did only one, right, thread T1, print numbers, and 10 we had given if you recall, and then T1 dot join. So, now what I will do, I have another thread, right. So, we are talking about the multi-thread, another thread T2, right. So, here you have print numbers, now ID is 2, right. So, T2 ID is 2. So, you have two threads T1 and T2 simultaneously, right. Simultaneously it has been started. Now, we know the meaning T1 dot join and T2 dot join, right. The last 3 states, 5 states we have studied, the first 2 are, right, the based on the thread T1 when you are creating or starting, right. So, now T1 dot join and T2 dot join. So, it will go up to the termination, and we know that, right, we are going to get, right, let us say either you will get thread 1 first or thread 2 first, alright. So, it is depending on the compiler, you have to run in various compilers, right. So, here in this case what I have got, so first I have got thread 1, right. So, meaning is one by one it will happen. So, first thread 1 and that is nothing but the ID. So, this ID will be printed, then the I values I is equal to 1 to 5 will be printed, right. So, next, that is what we had told over here, right. So, two threads T1 and T2 attempt to print the numbers, right. So, that is what the meaning here, line number 15 and 16, right. So, two threads T1 and T2 attempts to print numbers. So, now this class mutex, right. So, which is ensuring, right. So, here you go, right. So, this mutex, so which is ensuring, right. So, the thread safe access to the console output. So, here I have got thread 1 first. So, there is always possibility that thread 2 may come first. Yes, it is possible. So, one of them will be printed because of mutex. So, you may get, some of you may get, right. So, you run in various compilers, right. Some of you may get thread 2 first. So, thread 2 1 2 3 4 5 first, and then thread 1 1 2 3 4 5 next, possible, right. So, the same meaning, the T1 dot join and T2 dot join, we had seen only one case we had seen in the first program. So, that means the rest states, right, that runnable up to termination, right. So, that will be done and then you will get the output, right. So, here idea is you have through two threads T1 and T2, both are trying to print, right, this output at the same time, right. So, but you want the output one by one, right. So, for that what will you do? You have line number 8, line number 8 you have mutex. So, this mutex, right, STD scope resolution operator mutex, right, exactly we are using over here. So, this is useful, right, for the thread safe access, and then it is printing the number one by one, right, one by one in the sense thread by thread. First thread T1 and then T2 we have got, right. In some of the compilers T2 first and then T1 next, right. So, this is also possible. So, the next example we will see synchronization in Java, right. So, let us consider class counter, right, let us consider class counter. So, under class counter you have the private member data count 0, right. So, count equal to 0, private member data we consider count, and then you have a public, first time we are using synchronized void increment, right. So, the reason here is suppose there are two threads, right. So, we have to synchronize and then we have to do the increment. So, let us say one thread is running for I is equal to 1 to 10, right, and then you are doing the increment. Second thread I is equal to 1 to 10, you are doing the increment. So, total you should get 20, right. So, this we use with the help of the keyword called synchronize, right. Increment is doing count plus plus, and again synchronized because two threads will produce the resultant. So, the resultant we are printing return count. So, for this we require get count function, right, get count method. So, this is your class counter. So, now we will go to the driver class. Driver class is a main, you have the main program, main method over here. So, which is for the safer side, it throws interrupted exception. So, any exception occurs, so it will throw the exception, right. So, now you have counter object, the class is counter, and then the memory will be allocated with the constructor counter. Okay. So, when I am creating this, so the counter constructor will be called. So, we do not have any default. So, we will further proceed. So, here line number 16, this is nothing but the lambda expression in Java. Alright, lambda expression in Java. Alright, so here this is a runnable, the name is runnable, the task. So, these are all the syntax, right, followed by arrow, right. And then here you have for int I is equal to 0, I less than 1000, I plus plus, right. So, the lambda expression, this is useful when assume that you have two threads. In fact, we are going to have two threads. So, let us assume it is running. So, we know in the previous program in the C++, so we have got the output separately, right. One is the thread 1 and another one is thread 2. So, here in this case thread 1, so which will calling this counter increment every time for I is equal to 0 to 999, that means 1000 times, correct, and then another thread T2, right. So, we have to do the synchronization, correct. So, that is why we have used the keyword synchronization. So, two threads both produce the 1000, right, and then we will see what is the output that we are going to get. So, here I have created, so is over counter is invoking increment function, all right, and it is over, right. Your for loop is over and your lambda expression is over here, right. So, in the main class we have created two threads, T1 is a thread, T2 is also a thread, right, and then here you can see the thread is a constructor passing task, right. So, here you have the task, right, and then you are starting T1 dot start and T2 dot start, right. So, the previous program will help you, all right, in C++ that we had seen. So, T1 will run and T2 will run and then we have to do the synchronization, right. When the first thread runs, T1 runs, so the increment we will get 1000 or whichever runs, T2 can also run first, right. So, one of the threads without loss of generality, let us say T1, right, the increment will be how much, 1000, right. Next T2 increment will be 1000. So, next thread when it starts, so it will come, it will go from 1001, 2, 3 etc., right. So, the total increment will be 2000. So, this is your usual syntax. So, you are starting and then T1 and T2 are running, then you are completing with T1 and T2 join, right. So, just refer the first program in Java that we had seen, right. You use start and then join, right. So, here simultaneously two threads are running and counter dot increment when it is calling, it is a synchronized function or synchronized method increment. So, for T1, right, it will give 1000 and T2 it will give 1000 or other way around, right. Assume that first T2 is running, right. So, T2 will produce 1000 and T1. So, on the whole the total should be invariant, right. So, 1000 plus 1000 we should get the output 2000. Let us see, right, final count, this will be the output, all right, because it is in the double quote and then counter is calling get count, right. So, we have already have 2000. So, your get count function when it is calling, it will return count. So, the count is 2000. So, 2000 will be the output, right. So, 2000 will be the output. So, what we can do, we can run this code and we will see, we will go to the Java console, all right, and we will run the code. So, Java, right, count main, you can see 2000, okay. So, the same code. So, maybe what we can do, we can change to 500, 500, let us see. We open the Java code, right. So, here what I will do, I will change to the loop, let us say 500, just a check and then save the code, right. So, now again I will run here Java, I have to compile first, yes, successful Java, right. So, here you can see the output 1000, right. So, I have changed the loop to 500, right. So, 500 plus 500 it should be 1000, okay. So, this is how the synchronization is working in Java, right. So, in the next lecture I will start from the deadlocks, right, the causes and prevention we will see in the next class. Thank you very much.